In this problem, we're asked to use the transform technique to find V0 of t in the network below if V of t is 15 cosine 10t. And the way that we'll approach this is we'll convert over to the frequency domain circuit and find a transfer function which relates V0 of t and V of t. Once we have that, then we'll convert this to its equivalent Fourier transform and perform the analysis and then do an inverse Fourier transform. So first, let's take our circuit and draw it in the frequency domain, and I'm going to write the impedances as a function of omega for the inductor and the capacitor. So here is our circuit now that we've converted it. What I'm going to do also is going to start and combine impedances. So we've got these two in series, and that's in parallel with the J.1. Now what I'm going to do is I want to define this voltage as V1 of omega. I'm going to simplify this circuit, calculate V1 of omega, and then V0 of omega is a voltage divider from V1 of omega. So let's first calculate, I'll call it Z of omega, which is that combination. So we have J omega 0.1 times 2 plus 1 over J omega 0.1 divided by 2 plus J omega 0.1 plus 1 over J omega 0.1. And that becomes, let's see, J omega 0.2 plus 1. And then we'll have 2 plus J omega 0.1 plus 1 over J omega 0.1. Now, multiplying through by J omega 0.1 in the numerator and denominator, Z of omega becomes minus omega squared times 0.02 plus J omega 0.1 over 1 minus omega squared 0.01 plus J omega 0.2. So now we can draw a simplified circuit showing that impedance combination. So here's our circuit now. Now you can see V1 of omega on our diagram. So now let's use voltage division to express V1 of omega in terms of V of omega. So we have Z of omega divided by Z of omega plus 3 times V of omega. So we have minus omega squared 0.02 plus J omega 0.1 over 1 minus omega squared 0.01 plus J omega 0.2 over 3 plus that same quantity. Now, if we go in and simplify that, V1 of omega then becomes the following. Now, if we go back to our circuit, okay, we can see that V of omega can be determined from V1 of omega by voltage division. We'd have 2 over the sum of those two. So then V0 of omega is 2 over 2 plus 1 over J omega 0.1 times V1, and that's J omega 0.2 over 1 plus j omega 0.2 times v1 of omega. So now v0 of omega then is j omega 0.2 over 1 plus j omega 0.2 times minus omega squared 0.02 plus j omega 0.1 over 3 minus omega squared 0.05 plus j omega 0.7 times v of omega. So there's our relationship between v0 over omega and v of omega. Now, our source, v of t, is 15 cosine 10t volts. So the Fourier transform of that is 15 pi delta of omega minus 10 plus 15 pi times delta of omega plus 10. So now we need to go in and basically calculate or evaluate our transfer function at two different values of omega, omega equal 10, omega equal minus 10. So v0 at omega equal 10, we'd have j10 times 0.2 over 1 plus j10 times 0.2 times minus 10 squared 0.02 plus j10 times 0.1 over 3 minus 10 squared times 0.05 plus j10 times 0.7 times 15 pi. So v0 of omega equal 10 then is j2 over 1 plus j2, and this is minus 2 plus j1 over minus 2 plus j7 times 15 pi. And if we finalize the calculations, we wind up with 4.12 pi at an angle of 74.05 degrees. Now that's only part. Now we also need to go in and evaluate at omega equal minus 10. That would be this term. So v0 of omega equal minus 10, we'd have j times minus 10 times 0.2 over 1 plus j minus 10 times 0.2. We have minus 10 squared times 0.02 plus j times minus 10 times 0.1 over 3 minus 10 squared times 0.05 plus j times minus 10 times 0.7, and all this is going to be multiplied by 15 pi. So this reduces down to minus j2 over 1 minus j2 minus 2 minus j1 over minus 2 minus j7 times 15 pi. And it turns out to be 4.12 pi at an angle of minus 74.05 degrees. So v0 of omega is 4.12 pi e to the j 74.05 degrees delta omega minus 10 plus 4.12 pi e to the minus j 74.05 degrees times delta of omega plus 10. Now we've got to get that back to v0 of t. So we now need to do the inverse transform. So we're looking to say, well, v0 of t is the inverse Fourier transform of V0 of omega. So now, the inverse transform by the integral is 1 over 2 pi, integral from minus infinity to plus infinity of 4.12 pi, e to the j 74.05 degrees, delta of omega minus 10, plus 4.12 e to the minus j 74.05 degrees, delta of omega plus 10, e to the j omega t d omega. So if we go in there, the pi's are going to cancel out. And if we pull a 4.12 out, we're going to have 4.12 over 2. And all the pi's cancel out. We have e to the j 74.05, e to the j 10 t for this first term. Then we have e to the minus j 74.05, e to the minus j 10. And if we rewrite this as 4.12 e to the j 10t plus 74.05 plus e to the minus j 10t plus 74.05 over 2. And if we remember from using Euler's identity that this is the cosine, so we get 4.12 cosine 10t plus 74.05 degrees volts.